UniLabs is the university network of interactive laboratories, which web portal is based on Moodle. Our labs can be either virtual, based on mathematical models, or remote, which operate real devices at distance. The open course in UniLabs offers free access to some of our virtual and remote labs, and it is oriented to control engineering. Here, users can find several didactic units. 3 units are available at the moment. The first one is a DC motor that allows performing experiences on position and velocity control in a first-order system. The second one is a heat flow system for temperature control on a plant with transfer delays. The last one is the coupled electric drives, a system with 2 inputs and 2 outputs for MIMO control.
Let's enter the coupled electric drives virtual lab. In this system we have 2 motors, one at the left and one at the right. They are controlled independently with these 2 sliders. The motors are coupled with this yellow flexible belt. The belt passes through a jockey which is used to measure its velocity and tension. 2 control modes for tension and velocity are available, couple or decouple. In the PID tab, we can choose whether controlling one of these variables or the other. The reference for the belt tension and velocity are set using these 2 sliders. In order to activate the PID control, we click on the automatic button in the PID tab of the upper menu. Now we can choose the control of the tension of the belt and now the reference for the tension. In the tension tab of the graph at the right, we can see the evolution of the tension, which is going up to meet the reference marked by the blue line. An additional tool for this virtual lab is the Frequency Response Analysis tab, named AC Signals. These numeric fields allow the user to choose an amplitude and frequency for the input signal. Clicking the activation selector and choosing an amplitude, the laboratory begins an estimation for the magnitude and phase of the output signal, and shows the value in the AC graph. By using the automatic option, we can configure a sweep. For example, we can obtain 500 points between 0.1 and 50 Hz. And the student can see the advance of the sweep for a few minutes later obtainable the graph. At this moment, the user can save the data using the menu, and with a mathematical program, the student can obtain a graph like the next one using a collection of sweeps.
UNED is an open university, but of course it has real laboratories. As an open university here at UNED, we are experts on distance education. For years, we have been using virtual and remote labs for offering our students a way to perform their experimental activities at distance. Now, in the context of virtual and remote laboratories, an open course is a different and very big problem. The number of users that may access your course can be really huge, and you need a solution to be able to serve them with your open labs. Now, sometimes the solution for a big problem can be based on a small thing like this. By using the low-cost BeagleBone board and 2 free and open-source softwares, EJS for building the lab applications and Moodle to deploy them, we have been able to create an open course with 5 remote laboratories that are accessible for anyone in 24/7.
Let's now see the Capel Electric Drive's remote laboratory. By clicking the Start button, we can connect to the system and initialize the data exchange. As in the virtual version, we can change the value of the motor inputs and see the signals in the Velocity tab. After a few seconds, we can see these three signals reaching a common value, even if the user changed the input signal. The remote version includes a selector, the augmented reality, and clicking on it we see a visual estimation for the actual velocity of pulleys and motors.